Mr. Bozeman, would you please tell us about how you go about thinking outside the box, your innovative process?
Sure, I'll be glad to try. Thank you for asking. The patents that I have on file presently, some years back, I went through the patents looking at how I came up with the ideas. In fact, I was asked the question, how did you come up with this? So that prompted me to develop 16 gateways to innovation and creative thinking. So I'll try to go over some of those, not all of them, but some of the more critical ones. The first one I call asking children's questions, and that's very basic. You know, you look at something, you don't understand it, you don't want to ask, but it's very important that you do. Like the artificial heart device, the heart pump. I ask a very simple question, Dr. DeBakey, how does the heart beat? How does it work? Now that seems like a very simple question, but I did not know, and it was very critical for me to know to get involved in the development of the heart pump. Then adapting, number two. Adapting for the heart pump, I thought about what runs at high speed that's currently readily available. Well, I wanted to run at about 10,000 RPM, an ideal application for a computer disk drive. So that was adapting. Then dreaming. It's a very, very critical gateway because you think of problems all during the day. You go to sleep at night in your subconscious and you can solve a lot of problems. You wake up, you get up, you make notes of what you've been dreaming. And my wife thought I was crazy the first time I did that. Getting up, making notes. Then one called pressure. And what I mean by that is feeling a real personal need to solve a problem. I had a friend at NASA who had a major heart attack, and he kept bugging me, if you will, about building an artificial heart device because he needed one. He had a failed heart. He had Dr. DeBakey call me and asked me about building an artificial heart. Of course, I didn't know anything about hearts. And I told Dr. DeBakey that was out of my field, beyond my pay grade, but I was very honored that he would ask. So a week later he called back and said, how are you coming on the heart pump? And I told him I wasn't working on a heart pump. He said, well, you need to be. A couple of weeks later he came back and said, okay, what have you accomplished? And I said, well, I've been thinking about it. So pressure, you know, you feel pressure from people in need, someone who wants something done. The next gateway that I'll talk about is by accident. Accidents are a terrible thing in some cases. In some cases they're really not. They lead to development of something that will prevent accidents. So there in Houston I had a call from Limbs of Houston. A 12-year-old child had lost an arm in an accident, and they were calling wanting me to work on an artificial arm. The reason they needed something not really sophisticated is the young man did not have enough strength to use the old hook method, enough strength to pull the shoulder device. So I developed a device using an electrical transducer, which required minimum muscle movement. So that accident turned out to be something that was bad for him, yet it developed something for use in the future. The next one I call framing. That's simply looking at things in a different light. We had shuttle thrusters on the vehicle. Some were catastrophically failing about one time in 50,000. They were blowing up. The engineers were working on redesigning the thruster itself. I looked at it because I was in the test business, and I looked at it from a preventative standpoint rather than a remedy after the fact. So in the test stand one day, just before one failed, I heard a noise. just before it exploded. So it dawned on me, instead of them having to redesign the thrusters, if I could capture the frequency of that noise, come into a logic circuit to shut the engine down before it did explode, and then start it back up automatically. So that's an example of framing. Linear thinking, I can't imagine anything more suited to linear thinking than developing the heart pump, where you had day after day to look at blood damage, change this, change that, just keep going for like 8 years. So linear thinking. Nonlinear thinking is another gateway. Nonlinear is another application for the heart pump. We all know of the heart being a pulsatile device, and so we were looking as a team for continuous flow. So we had to transfer thinking from a pulsatile device, which has many moving parts subject to fatigue, to a continuous flow device. So that was kind of a nonlinear application. And then brainstorming. I can't really say enough about teamwork. Developing the heart pump, as you might well imagine, required many, many skills from biocompatibility, electronic control, mechanical engineering, computer diagnostics. So it took a whole team of people. Fortunately, we had dedicated people who spent all those years working together with many, many arguments, many, many conflicts, but it worked out. So we're grateful. Then computer thinking, that's kind of a tongue-in-cheek. I've never had a computer think for me, but it's amazing what you can do with visualization, like computer flow dynamics, to look at the dynamics of the pump. Just a great tool. Then documenting, which is extremely important. One of the admirals, Admiral Rayburn, said many years ago, if you can't write it down, you don't know what you're doing. And that's absolutely true. We found that in doing the patent work, that if you start writing down what your thoughts are, getting it ready to patent, getting it ready to work, oftentimes you find it won't work. So it's a great tool to make your mind active in what will and won't work. Plus, a month or two later, you can go back and see where you were and not have to wonder, what did I do that for? So those are a few of the gateways that I use to innovate.
All right. Would you tell us a little more about your work with Dr. DeBakey and some of the stories behind that process?
Yeah, Pam, if you would let me go back a little bit,
Okay.
a few years back. The very first patent on a heart pump was, guess who? Does anybody know?
DeBakey?
No,
No?
no. Kind of a trivial trick question, but it was Paul Winchell,
Okay.
a ventriloquist with no medical background. Now, for years before that, there were many medical journals with people thinking about heart pumps, but with no hardware. But he was the first one to get a patent on a total artificial heart. Nothing ever became of it, and some years later, he donated that work to the University of Utah, to a Dr. Koff, K-L-O-F-F. And he worked many years on it. He also worked on artificial kidneys, other artificial internal organs. One of his students was Rob Jarvik, as you know. And what I'm leading to, there's a lot of controversy in inventing, just in general, but at some point, Dr. Jarvik, who was a student of Dr. Koff, took the design of the pump and got a patent on it called the Jarvik 7. Well, a very distraught Dr. Koff was devastated. He didn't know what to do to pass it. And at the same time, well, as you remember, the Jarvik 7 was used for a very short period of time. Now, at the same time, Cleveland Clinic was very active in artificial heart work, total artificial heart. And there was a doctor there, a PhD, MD, by the name of Dr. Noze, Yuki Noze, who eventually came to Houston to Baylor College of Medicine with Dr. DeBakey. Had the privilege of working with him for about 10 years. At any rate, Dr. DeBakey and Dr. Cooley were working on an artificial heart, total artificial heart. And Dr. Cooley, while Dr. DeBakey was at a conference in New York, implanted the pump, causing great controversy because Dr. DeBakey said he wasn't ready for human implant. So we had another disagreement and parting of the ways of two more doctors. Total artificial hearts, there was a moratorium placed on them about that time. Reason being that they were not successful. So Dr. DeBakey in the 1960s had implanted an artificial heart assist device, a huge device requiring a console, turning at low speed. That was pretty successful, and he never forgot that. So when he contacted me, he had already done a little bit of continuous flow work. Dr. Noze is the one that had done most of the continuous flow work. So now we had a team of the guy who said it could be done, and a team of engineers who would work with him. So we had a great time working with Dr. DeBakey, and we asked a lot of children's questions. But it was a great experience, and we're just proud that it came to pass.
You've mentioned children's questions a couple of times. What is the most important childlike question a student can ask?
I guess the question why. If they see a device, they should not be scared or intimidated by the instructor to not ask the question. Any question you come up with is a valid question. That's what my take on it is.
Well, Mr. Bozeman, I want to thank you for doing this for our students. We truly appreciate it. And if you have any parting words, please feel free.
No, that's about it, but thank you very much for having me.